Now that colonizing other planets no longer seems to be a fantasy, we should stop for a moment to think about what to do. Terraforming a world without an atmosphere at a not optimal distance from the sun is no small matter. Building bases on the surface without even the protection of a magnetic field. What alternatives do we have left? Let's look at an idea almost as a joke by the physicist O'Neill of Princeton University. An idea first published in 1974. Building an artificial world could be an alternative, but doing it is not a joke. There are so many things to consider. You have to replicate the gravity of the Earth, the day and night cycle, and the presence of sunlight, provide for the production of food and water, maintain a constant temperature, and much more. Even if we are used to considering these worlds as geoids, the moment we create one from scratch, things will change. Imagine two hollow cylinders rotating on their own axis in the opposite direction of each other. Rotation serves to create stimulated gravity by centrifugal force, which means that the habitable part, and subject to gravity, would be the inner surface of the cylinder. This surface is divided into alternating strips. The first are intended to house parks and forests with lakes, rivers, grass, trees, and carefully selected animals. All the most attractive and familiar the Earth can offer to humans. The others are windows to allow sunlight to penetrate into the cylinder, of which the side surface is always facing the sun. The light is bounced off large mirrors to ensure optimal diffusion, and the arrangement of the windows is such that one of them will always be facing the star. But how big should the living cylinder be? How many people could live there? The maximum dimensions suggested for the first one, for economic reasons and because of the availability of materials, is 4 miles in diameter, 6.5 kilometers, and 16 in length, 25.5 kilometers. The four models proposed by the physicist range from a minimum of 10,000 to a maximum of 20 million inhabitants, depending of course on their size, which means that these worlds would be more like today's megalopolises. The day and night cycle would be guaranteed by the rotation of the mirrors, and the temperature would be regulated according to the exposure, thanks to a few 100 million cubic meters of water crammed into the cylinder. It would be interesting, given the lack of need for areas for agriculture and industry, to include in the cylinders animals at risk of extinction, precisely because of the reduction of their natural habitat for the same human needs on Earth. Agriculture would be entirely moved to special cylinders, sterile environments free of insects or pests, so even pesticides would not be needed. The food available would always be fresh because the cylinders would be so close to each other, and there would be no need for transatlantic or transcontinental transport. The same would apply to industrial structures. Dangers such as being affected by a celestial body, considering the small average size of an artificial world compared to a planet or a moon, are very scarce. And for smaller bodies, the construction of the cylinder with more external layers should be sufficient. This must of course be accompanied by constant monitoring and maintenance over time. Life in cylinders would be more idyllic than in many places on Earth today. With plenty of free food and energy, electric means to cover distances not comparable to planetary ones, the lack of need for heating or propulsion systems based on fossil fuels, and therefore no smog or noise pollution, an artificial world would be a small Eden. Even the means of transport from one cylinder to another, starting from a situation of absence of gravity and having to move in the vacuum, would be small and simple, not comparable to the spaceships that we know today. The cost of realization indicated by O'Neill is about $210 billion today, a figure that must be carefully evaluated in light of new technologies, knowledge, and materials available compared to when the article was written now 50 years ago. That sounds like a huge amount of money, but when putting it into perspective, it's not. $210 billion is just over 5% of Germany's gross domestic product in 2019. Considering also that such a work would involve all or most of the nations of the world, all of a sudden the amount needed would no longer be so shocking. The new space colonies, moreover, would be less expensive than the first and faster to build because they would start from the first, built directly in space, eliminating the onerous need to transport material, machinery, and people from Earth. Ultimately, instead of colonizing planets and moons to terraform them, or create underground civilizations protected by shields because of the local atmosphere, having to undergo rotation and revolution and distance from the sun and all related problems, the construction of a world tailored to the human species from scratch seems like a good idea to invest time, resources and money in. We hope the video has entertained you, interested you, and why not, inspired future governments and tycoons to invest in this possible future. Below in the description, there are a few links where you can learn more about some aspects covered in the past few minutes. And of course, there is our Patreon. By adopting a spaceship and financing even with just a little this project, you can make possible new journeys into the cosmos and into curiosity. Don't forget to subscribe, share the video with your friends, and leave a comment. And we'll see you on the next video.